You ever just look at the world and wonder, you know, why does bread get all fluffy when it bakes? Or why do leaves put on that incredible color show every fall? It's that feeling, right? That little spark of curiosity, that need to understand how things actually work. Well, today, we're going to chase that feeling.
This line from the chemist Primo Levi just hits the nail on the head, doesn't it? It's about that deep human drive to figure it all out, from why a rock sparkles in the sun to how our own bodies even function. And believe it or not, that huge quest for knowledge, it has a name: chemistry.
And that's really where our journey of understanding leads us, straight to chemistry. Now I know, the word itself can sound a little intimidating, maybe it brings back memories of complicated lab classes, but it's really just the science that explains the world you see and touch every single day. In fact, you've probably asked a bunch of chemistry questions today and didn't even realize it. Okay, think about your morning. You're making tea or coffee. You see the water start to bubble, turn into steam, and float away. But the metal kettle just sits there, solid and hot. Why? That's not just a random thought. That is a pure chemistry question.
Or what about when you're driving your car? How on earth does a tank full of liquid gasoline turn into the power that moves this giant metal box down the road? And what exactly is that stuff coming out of the exhaust pipe? Yep, chemistry again. Here's a weird one. Go to a library. You might pick up a book from, say, the 1970s, and the pages are all yellow and brittle. But then you see a book from the 1700s, and it's in perfect shape. How is that possible? Well, it all comes down to the slow-motion chemical reactions happening in the paper itself.
So you see the pattern here? All these everyday puzzles, from your kitchen to your car to the library, they all have answers. And the key to unlocking those answers is chemistry. So what is chemistry, really? When you strip it all down, it's just the study of matter. You know, the physical stuff that makes up everything, and trying to figure out what it's made of and why it acts the way it does. Simple as that. But here's the thing. Chemistry isn't just a giant encyclopedia of facts you have to memorize. No, it's actually a process. It's a powerful step-by-step way of turning that "I wonder why" feeling into a real solid answer. It's a method for discovery.
And that method is the famous scientific method. It's a loop, really. It all starts with just observing something interesting. That leads to a hypothesis, which is basically a fancy word for an educated guess. Then, you test that guess, you experiment, you see what you find, and you use that new info to make your guess even better. It's this amazing cycle that gets us closer and closer to the truth. But look, this isn't just some abstract idea on a slide. Let's see how this powerful method was used in the real world to crack a huge medical mystery. So back in the 1960s, scientists made an observation. Manganese miners were showing symptoms that looked a lot like Parkinson's disease. That sparked a hypothesis. Maybe there's a chemical link. They discovered manganese messed with a brain chemical called dopamine. So they refined their hypothesis. Maybe Parkinson's patients have low dopamine levels. They tested it through brain studies, and bingo, they were right. And that discovery led directly to an application, the creation of the drug L-Dopa, which helps restore dopamine. See? From a simple observation to a life-changing treatment, that's the method in action. Okay, so for scientists to test their ideas and share what they find, they can't just be like, "I used a little bit of this," or "it got pretty hot." They need a super precise, universal language so that an experiment in Japan can be understood perfectly in Brazil. And in science, that language is all about measurement. The best way to think about it is this. You can't read a book if you don't know the alphabet, right? Well, in science, measurement is the alphabet. It is the absolute non-negotiable foundation that everything else is built on. So let's start with one that trips a lot of people up. Mass versus weight. They sound the same, but they're totally different. Your mass is the amount of stuff you're made of. That number stays the same whether you're on Earth, on the moon, or floating in space. Your weight, on the other hand, is just the force of gravity pulling on that stuff. So yeah, you'd weigh a lot less on the moon, but your mass, the amount of you, wouldn't have changed one bit. Now, to make sure everyone is speaking the same language, scientists all over the world use something called the SI, or the International System of Units. Here are some of the big ones. Length is in meters, mass is in kilograms, time in seconds, and temperature, this is an interesting one, is measured in Kelvin. 0 K. So what does that even mean? What on earth happens when you get to 0 Kelvin? That, right there, is absolute zero. You see, temperature is really just a measure of how fast particles are moving and jiggling around. The hotter something is, the faster they're moving. Well, at absolute zero, all of that motion completely, utterly stops. It's the coldest anything can possibly get. It's like the universe's ultimate stop sign for temperature.
So we've got a method for asking questions, and we have a precise language for finding the answers. Now let's see how we can put those two things together to create some real-world breakthroughs. And a great place to start is with an idea called green chemistry.
This quote really sets the stage. As we learn more and more about how to manipulate chemicals, we also gain a responsibility to use that knowledge wisely, right? To think about the consequences. And that powerful idea is the whole foundation of the green chemistry movement.
At its heart, the goal of green chemistry is pretty simple. Let's try to design products and processes that are safer for people and for the planet. It's about being clever and innovative in a way that's also sustainable.
And here is a fantastic example of it in action. The problem was huge. Barnacles and other stuff growing on ship hulls were costing the shipping industry billions of dollars. The original solution was to use paint loaded with toxic chemicals that poison the ocean. Not good. But then came the green chemistry solution, a product called C9. It works like a charm to keep the hulls clean, but here's the brilliant part. It breaks down harmlessly in the water afterwards. It solves the problem without creating a new one. That's green chemistry.
This old proverb just wraps everything up so perfectly. We started this whole journey by just hearing some interesting questions. Then we saw the methods that scientists use to get to the answers. But it's that final step, the doing, that leads to real, true understanding.
And that's what we want to leave you with. This world is absolutely packed with amazing questions that are just waiting for an answer. So now that you've seen the playbook, what are you curious about? What little corner of your world are you going to decide to understand next?